Hi, in this tutorial I'm going to complete question 2bii from NECTA 2017 and is from Basic Applied Mathematics Form 6, and it is to do with stationary points. Okay, so I have completed 2a and I've completed 2bi in my previous videos, so you can go ahead and watch that at your own time. I'm now going to complete 2bii, which is this question here. It is not related to any of the above questions, so you can continue to watch this video. Okay, it says describe the nature of the stationary points of the function, this one here, and then show them on the graph. Okay, so we're talking about stationary points. Okay, so what are stationary points? Is where the graphs would turn. So for example, if we go like that, or you have one that goes this way. So stationary points are where the graphs start to turn. So these are actually called turning points. Okay, these are called turning points. So turning points here as well. When we have it this way, that will be the maximum value of the graph. So this is called the maximum value. So maximum, that is the nature is, sorry about my pen. This is maximum and this is the minimum. And that is what we are asked to describe, whether it is maximum or minimum. Okay, let's just do the first step. So what actually happens here at a stationary point is that the gradient at this point is 0. Okay, at this point, imagine it's a ball that goes over this way, and then it gets to a point where it stops and then it starts to come down again. So the gradient is 0. So gradient at stationary point is 0. So what we say, gradient is equal to 0 at stationary points or turning points. Okay, so we have the function of x as 2x cubed minus 15x squared plus 24x. To get the gradient for this function, we need to differentiate. So say dy dx. Okay, so function of x as in y equals all this. So dy dx then is going to be 6x squared minus 30x plus 24. So at stationary point, okay, at turning point, stationary points, dy dx is equal to 0. This means now we can say 6x squared minus 30x plus 24 is equal to 0. Divide by 6 throughout, you will get x squared minus 5x plus 4 equals to 0. Okay, this can be factorized, so that means you have x minus 1 and x minus 4. Therefore, you have x equals 1 and x equals 4. So you need to find the values of y when x is equals to 1 and when x equals to 4. So we're going to find y. So when x equals to 1, y is equal to, we need to sub in into our original function. Sub in as in substitute. So you have 2 1 cubed minus 15 1 squared plus 24 1. So this gives you y as 11 if you work that out. So when x is equal to 4, again, y is equal to 2 4 cubed minus 15 4 squared plus 24 and 4 inside, and this gives you y as in negative 16. So let's just put our turning points in, or stationary points. So the stationary points are, we've got 1 when x is 1, y is 11, so 1 and 11, and when x is 4, y is negative 16. So this is where the graphs turn. But we now need to know which one of these is a maximum or minimum. What do we need to do? Well, we can use second differentiation to find out the turning point. So we need to do d2 dy, d2y dx squared, and at stationary points, if this is greater than 0, then what we have is minimum point. It's a minimum point. Okay, if this differential, second differential, is less than 0, then we have a maximum point. Okay, so let's just do the second differential then. We have dy dx is 6x squared minus 30x plus 24. What we can do now is d2y dx squared is going to be equal, differentiating that's going to be 12x minus 30. Okay, now we need to put the values of these turning points. So when x equals 1, what do we get? We get d2y dx squared is equal to 12, 1 minus 30, which is going to be minus 18. Okay, so when x is equal to 4, what do we have? We have d2y dx squared is equal to 12, 4 minus 30, so that's 48, take away 30, which is 18. So now we have d2y dx squared equals to negative 18 and 18. And what did we say? When d2y dx squared is less than 0, then we have maximum. Okay, this is going to be maximum. So when x is equal to 1, this is your maximum point. And then when x is equal to 4, d2y dx squared is 18, which is greater than 0, then this is going to be your minimum point. Okay, so this is your minimum stationary point. So you can go ahead and draw this properly on your piece of paper. This is just to help you now just get some understanding. Okay, so we have a turning point, one at 111, so somewhere here. We have the maximum, so this point here, I beg your pardon with my pen. So we have 1 point there, so this point is going to be 111. Okay, and then we have 4, negative 16, so let's say somewhere here, and you need to say that is 4, negative 16. So describing the nature of stationary point, so then you say the point 111 is the maximum point, and the point 4, negative 16 is the maximum. So minimum, and this is your maximum. You can show that on a graph. Okay, so hopefully this will help you to get on with some revision for your exam. Thank you for watching, and please don't forget to like and subscribe. Bye for now.